Hello, welcome again. We are covering the subject compressible fluid flow for civil services means IFS and GATE aerospace exam. So we are covering the topic oblique shock and solving some numerical based on that topic. And we have solved one question, and now second question is, which is also the part of the first question, is, so it consists of two parts. First is, in previous question, in question number 1, if the deflection angle is increased to theta is equal to 30 degree, calculate the pressure Mach number behind the wave and compare the result with the previous question. So here in the previous question, the Mach number was 3 and angle was 20 degree. Now the Mach number is same, that is 3, but reflection angle is 30 degree. So now from this theta beta and Mach diagram, you can see that this is your 20 degree. So now it is 30 degree. So this is your 30 degree and Mach number is 3. Okay, and this is the angle. So this is approximately 52 degree. In the previous question it was beta comes out as 37.8, and in this we get beta as 52 degree. So the normal Mach number will change, that will be your m1 sin beta, so that is 3 sin 52, so that is 2.364. Okay, so that is your normal Mach number. Okay, now from normal Mach number 2.364, from the choke table we can see the pressure ratio and downstream Mach number also. So this is your choke table, and now it is the Mach number is, normal Mach number is 2.364. So 2.35 is this, and corresponding to this we are getting approximately 0.53. So it is 0.5286 or 0.53. Okay, and the pressure ratio on the same line we can see that is 6.276. So initial pressure is 1 atmosphere, so P2 will come out as 6.276. Okay, and this Mn2 is your 0.5286, so we can find out M2 using Mn2 divided by sine beta minus theta. So beta is your 52 and theta is your 30, so it is beta minus theta is 22, so M2 will come out as 1.4. So in this question, when we increase theta by 10 degree, we can see that the beta is increasing, and the beta is increasing, and in the previous question we got the pressure ratio, pressure, final pressure as 3.783, and here we have got the pressure as 6.276, and here Mach number we have got 1.41, and in the previous question we got it as 1.98. So it means the Mach or the final Mach number or the downstream Mach number is decreasing. It means the stroke is stronger and pressure is also increasing. Okay, that is now 6.276. So it means when theta is increased, the shock wave becomes stronger. Okay, so reading this, so when theta is increased, the shock wave becomes stronger, as evident by the increased pressure behind the shock. The Mach number behind the shock is reduced 1.41 compared to 1.98. Also, as theta is increased, beta also increases Now it is 52 compared to 37.8 in the previous question. So now second part is, if the free steam Mach number is increased to 5. Initially it was 3, now it is 5. So from theta beta m chart corresponding to m1 is equal to 5. Theta is same, that is in the first question it is 20 degree. You can see corresponding to m1 is equal to 5 and theta is equal to 20. So m1 5 is this line and this is your theta. So this is your theta. So we will get the beta as 30 degree approximately. So beta is your 30 degree. Okay, so now we can calculate again same way mn1, that will be your m1 sin beta, so that will be 5 sin 30, that is 2.5. And now we'll see the shock table corresponding to 2.5, and corresponding to 2.5 the pressure ratio is, this is 2.5, this is the pressure ratio 7.1. The pressure ratio is 7.125 and mn2 is 0.513. So we can find out the final pressure, because initial pressure is 1, and we can find out the final Mach number also. So that will come out as the same formula, that is mn2 sin beta minus theta, but here beta is 30 and theta is 20. So beta minus theta will be 10, so m2 will be 2.9. Okay, so when m1 is increased, okay, here we have increased m1, we can see that the shock becomes again stronger, because this pressure is more than the previous pressure that we have got for m1 is equal to 3, that was 3.783. Okay, and Mach number behind the shock also increases, that is now 2.95 as compared to 1.988. Okay. Initially it was this. So as m1 is increased, beta is decreased. It was 37.8 in the first question, now it is 30. So these are the results. Now more conclusion can be drawn. First is, anything that increases normal component of Mach number ahead of the shock. So in both the cases, mn and mn1, in that case the mn1 n1 is the 2.364, and in the second case it is 2.5, whereas in the first question it was 1.8. So in both the cases mn1 is higher as compared to the first case.